Heap leaching. This technique is used for extracting metals from sulfides, particularly in gold and copper mining. The ore is placed in a heap and sprayed with chemicals like cyanide that dissolve the metal, which is then separated from the heap. Placer mining for native elements. For native metals like gold, placer mining is often used. Gold is frequently found in riverbeds, so mining in these areas involves the use of water to wash away lighter materials and concentrate the gold. Flotation for oxide. For many oxide ores, flotation is used to separate the metal-containing mineral from waste material. It's often followed by refining processes like electrolysis or smelting. Drilling and blasting for carbonates. In carbonate mining, especially for limestone and dolomite, blasting techniques are used to fragment the rock before it is crushed and processed. Emerging technologies in non-silicate mineral exploration. AI and machine learning. Artificial intelligence is increasingly being used to predict the location of non-silicate mineral deposits. By analyzing geological data, AI can identify patterns and make predictions that help reduce the cost and environmental impact of exploration. Biomining. This technique uses bacteria and other microorganisms to extract metals from ores. For example, bioleaching uses microbes to break down sulfide minerals and release valuable metals like copper, gold, and silver. It's a cleaner and more sustainable alternative to traditional smelting. Nanotechnology. In material science, non-silicate minerals like fluoride are being explored for their potential in advanced material science, including the creation of nanomaterials used in electronics, medical devices, and energy storage. Sustainability and ethical considerations in mining. The future of mineral exploration and mining will increasingly hinge on sustainability, with a greater emphasis on reducing the ecological footprint and ensuring ethical labor practices. Water recycling and management. Mining operations often use significant amounts of water, especially in processing or many companies are investing in technologies that allow them to recycle and reuse water, minimizing their impact on local water resources. Eco-friendly mining. To limit environmental impact, the industry is looking for ways to reduce the use of harmful chemicals, minimize land disturbance, and rehabilitate sites more effectively. Non-toxic alternatives to cyanide for gold extraction, for example, are under investigation. Ethical sourcing and fair trade. Ethical sourcing initiatives are aimed at ensuring that minerals used in products like electronics and jewelry come from mines where workers are treated fairly, and environmental standards are maintained. Efforts to ensure transparency and responsible mining practices are growing. Circular economy. The recycling of non-silicate minerals, such as rare earth metals from electronics, is becoming a critical area of focus. This reduces the need for mining and minimizes the environmental costs associated with resource extraction. The future of mining and exploration. The future of silicate and non-silicate mineral exploration is poised to be shaped by both technological advancements and a growing focus on sustainability. Innovations in mining technologies, such as autonomous vehicles, drones, and AI-powered exploration tools, will make it easier to locate and extract minerals while reducing environmental impacts. At the same time, the industry will need to adapt to global trends like the electrification of transportation and the increased demand for rare earth minerals, which could drive further advancements in recycling technologies. Let's keep expanding on the exploration, mining techniques, applications, and sustainable practices for silicate and non-silicate minerals, focusing on emerging innovations, industry shifts, and future trends. Further deep dive into silicate minerals. Rare and complex silicates. Beyond the common silicates like quartz and feldspar, rare silicates can have important applications in various high-tech and advanced industries. Some examples of these rare silicates include andalusites, sillimanite, and kyanite. These three minerals are polymorphs of aluminum silicate and are commonly used in the production of refractory materials. These materials are highly heat-resistant, making them ideal for use in furnaces, kilns, and jet engines. Topaz. This silicate mineral is well known for its use as a gemstone. However, it also has applications in electronics and optics due to its durability and resistance to heat. Topaz is also used in certain types of solar cells and LED technologies. Beryl. Known for producing gemstones such as emerald and aquamarine, beryl is also important in industrial applications. It's used in the production of nuclear reactors due to its ability to withstand radiation and heat. Tektites. These are natural glass formations that form when meteorites impact Earth's surface. Composed of silica, They're considered part of the silicate group and are studied for their properties in aerospace technology. Clay minerals, smectite group. These minerals, such as bentonite, are not only important for ceramics and construction, but also have uses in environmental engineering. Bentonite, for example, is widely used in the containment of hazardous waste, due to its ability to absorb contaminants. Mineral exploration advancements in the methods for exploring and extracting silicate minerals are becoming increasingly sophisticated, especially with the integration of new technologies. Geochemical surveys. In addition to traditional geological mapping, geochemical analysis of soil and rock samples is being used to identify silicate mineral deposits. Geochemists analyze trace elements in the samples to locate areas with potential for rich silicate resources. Ground-penetrating radar (GPR). This technology is increasingly being used to detect silicate mineral deposits at shallow depths, especially in areas where traditional drilling is not feasible. GPR uses electromagnetic pulses to create a detailed image of the subsurface, allowing for efficient exploration of silicate deposits. 3D seismic imaging. This technique, commonly used in the oil and gas industry, is being adapted to locate mineral deposits, including by mapping the Earth's subsurface in 3D. Geologists can more accurately pinpoint areas rich in silicate minerals. Laser-induced breakdown spectroscopy (LIBS). LIBS is a cutting-edge analytical technique used to analyze the composition of materials by using a laser to create a plasma. This technique is being employed in mineral exploration to rapidly assess silicate rock samples for their mineral content. Recycling and waste minimization in silicate mining. As demand for silicates increases, more focus is being placed on minimizing the environmental impact of silicate mining, particularly with the rise of recycling technologies. Recycling glass. One of the most significant applications of silicate minerals is in the glass industry. Recycling glass significantly reduces the need for raw silica and other ingredients. This process not only conserves silicate resources, but also saves energy compared to producing glass from raw materials. Recycling of electronics. With the increasing demand for electronics, silicate-based minerals like quartz are being recovered from This reduces the need for new silicate mining and helps address the growing global issue of electronic waste. Sustainable glass production. Advances in the use of recycled materials for glass production are contributing to a reduction in the extraction of new silicate resources. Using post-consumer recycled glass in manufacturing can cut energy consumption and carbon emissions by up to 30%. Further deep dive into non-silicate minerals. Advanced non-silicate applications and emerging uses. Non-silicate minerals are integral to a wide range of industries, and their applications continue to grow as new technologies emerge. Here are some advanced uses. Lithium from non-silicate ores. Lithium found in spodumene, a silicate mineral, and other non-silicate ores, is critical for the production of rechargeable batteries used in everything from smartphones to electric vehicles (EVs). With the global push for sustainable energy, lithium extraction and its associated technologies are seeing rapid growth. Magnesium from dolomite. Magnesium derived from dolomite, a non-silicate carbonate mineral, is increasingly important in aerospace, automotive manufacturing, and electronics due to its lightweight nature and strength. It's used in the production of magnesium alloys, which have applications in electric vehicles and high-performance sports equipment. Use of rare earth elements, REEs, such as neodymium and dysprosium, which are found in non-silicate minerals like bastonsite, are essential in manufacturing magnets used in wind turbines, electric vehicles, and renewable energy technologies. The growing demand for clean energy has spurred a surge in rare earth mining and recycling initiatives. Bauxite for aluminum production. Bauxite, a non-silicate mineral, is the primary ore of aluminum. As aluminum is lightweight and corrosion resistant, it is used extensively in industries like aviation, automotive, and packaging. New technologies in aluminum smelting are helping make the extraction of aluminum from bauxite more efficient and environmentally friendly.